difficult ones. Let's start with 2. This is cosine of, I'm going to use x rather than t, so cosine of x is equal to rad 3. And then they tell you on domain, it says on, and this is the domain from negative 2 pi to 2 pi, including 2 pi, negative 2 pi. What does that mean? Is they want you to find all the answers, go around the circle this direction, and also go around the circle in this direction. So 2 pi to negative 2 pi. Okay, what we're trying to do is we're trying to find out where this equation, if you were to graph y is equal to cosine of x, or 2 cosine of x, it's going to look something like this. Okay, that's at 2, and it's at negative 2. Now, if you were to graph y is equal to rad 3, okay, let's continue this curve to the left side. Okay, let's say that's at, this is at 2 pi, and this is negative 2 pi. So that's what we're looking at, because that's our domain. So, if you have y is equal to rad 3 is somewhere there. That's my rad 3. If we were to draw a horizontal line, because this is a horizontal line, if you were to draw a horizontal line from negative pi, negative 2 pi to 2 pi, how many places does it cross? That's what we're trying to find. Okay, how many places does it cross? Well, this is just a sketch. Okay, so it's not accurate. So we're going to find all the answers using algebra, which is more accurate. Okay, let's see. You can also do this using graphing calculator, but you can't use a graphing calculator. First thing I'm going to do is I'm going to divide both sides by 2. So I have a cosine x is equal to rad 3 over 2. Okay, now I have to ask myself this question: where is cosine equal to rad 3 over 2 on the unit circle? Well, on the unit circle, it's equal to rad 3 over 2 here. Okay, because that's rad 3 over 2. Positive, and that's my pi over 6. Okay, and if you go all the way around, it's also rad 3 over 2 here. Okay, and that is 11 pi over 6. So those are 2 places. Okay, we started here and then went around. So we have, so far we have x is equal to pi over 6 and 11 pi over 6. Okay, now we have to go in the negative direction. So we're going to start here, and if you go down, and that's going to be negative pi over 6, okay, because that's rad 3 over 2. And then if you keep going all the way around, we'll land here, and that'll be negative 11 pi over 6. So we get 2 more answers, and that is negative pi over 6 and negative 11 pi over 6. Those are the 4 places, and that's it. So that's an easy one. Okay, so let's go to more challenging one like number 4. Okay, in number 4, you have a 2 sine of 5x plus 4 is equal to negative rad 3. Okay, there is no domain restriction. Here, domain is really negative pi to positive, negative infinity to positive infinity. So if there's no domain restriction, then you're going to write the answers a little differently. But first things first, we're going to divide everything by 2. So I have a sine of 5x plus 4 is equal to negative rad 3 over 2. Alright, if I just had an x right there rather than 5x plus 4, this would be easy, but it's not. It says 5x plus 4. So what we're really asking is sine, and we'll just call this our little box something. Okay, well that should give me negative rad 3 over 2. So what can I put in that box, okay, to give me negative rad 3 over 2 for sine? So I go to the unit circle, okay, Negative rad 3 over 2, sine negative rad 3 over 2 means it's got to be here, because that's negative rad 3 over 2. And where is there? And that's going to be 4 pi over 3. Okay, and then it's got to be here. And where is there? And that is 5 pi over 3. Because that's negative rad 3 over 2 also. That's my sine. Okay, that's going into... those are two places. So I don't have to go negative direction because I can write this as a plus or minus. So I can either have here, I can have a 4 pi over 3 in the box, or my box could also include a 5 pi over 3. Now I could use negative pi over 3, doesn't matter. Okay, so I'm just going to use 5 pi over 3. Now here comes the complication. The complication is this: my 5x plus 4 is my box. Okay, that has to equal to 4 pi over 3. And since I'm going all the way around the circle many times, infinite number of times, that means I got to keep landing at that spot. So every time I go around 2 pi, I keep landing on that spot. So I have to go plus or minus 2n pi. And my n could be 0, 1. Okay, and you have to write that. Okay, n could be 0, 1, 2, 1, 2, dot, 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 dot. Okay, now I have to solve for x. I only solve for 5x plus 4, so I'm going to take the 4 to the other side. I have a 5x is equal to negative 4 plus or minus 4 pi over 3 plus, no plus or minus, plus 4 pi over 3, and then plus or minus, and then plus or minus 2n pi. Okay, now I still have 5 to get rid of, so I'm going to divide everything by 5. That means I have to divide everything by 5. I get negative 4 over 5 plus 4 pi over 15 plus or minus 2n pi over 5. And my n is equal to 0, 1, 2, dot, 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 dot. And that is one of my solutions. That just tells me I'm going around the circle, landing on that spot forever and ever, both counterclockwise and clockwise. Okay, I still have to take care of this, the second part. I'm going to do the same thing with the second part. So first of all, we know that 5x plus 4 is equal to 5 pi over 3 plus or minus 2n pi. Of course, we already stated what n was, so I'm not going to restate that. So I'm going to take the 4 over to the other side. I get 5x is equal to negative 4 plus, keep doing it, trying to jump ahead. There's no plus or minus here, so just a plus, okay, plus 5 pi over 3. Now I have plus or minus 2n pi. I still have to divide by 5, so my x is equal to negative 4 over 5. Okay, plus, when I divide this by 5, the pi's going to cancel. I'm going to get pi over 3, and then plus or minus 2n pi over 5. And my n is equal to 0, 1, 2, dot, 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 dot. And those are my solutions. How many solutions are there? Infinite number of solutions. Because I'm going around the circle forever and ever and ever. Okay. Now it's getting complicated, so let's get to even more complicated problem like number 6. Okay, so this is number 6. I have a sine of 4x is equal to 1. Okay, and I have a 0 and pi. Now I do have a restriction here, anything between 0 and pi. Okay, so that means anything from 0 to pi. Any solutions I get here, okay, I'm going to keep those. Alright, so this is 4x. I already solved for sine, so this is my Mr. Box. Well, what is that has to turn into? So when I take sine, it turns into 1. So sine is 1 only one place, which is right there, and that is pi over 2. So my box has to be pi over 2. Well, my box happens to be 4x, which is equal to pi over 2, and I gotta keep jumping forever and ever. So I'm gonna go plus or minus 2n pi, and is equal to 0, 1, 2, dot, 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 dot. Okay, last time we just went to the unit circle and found our values when we had a domain restriction. But that's because we had an x, we didn't have 4x. Because we have 4x, this is a little more complicated. Now we're going to solve for x, divide everything by 4, so I'm going to get x is equal to pi over 2, or pi over 8, because when I divide, that will turn to pi over 8. Okay, plus or minus 2n pi, okay, 2n pi over 4. Okay, and my n is equal to 0, 1, 2, dot, 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 dot. Okay, I can clean this up a little bit. That and that reduce, I get 2. I get my answer to be pi over 8 plus or minus n pi over 2. Alright, now I'm not done, because I'm only looking for values between 0 and pi. So I have to take the 0, put it in for the n. So I'm going to let my n is equal to 0. That means my x is equal to pi over 8 plus 0, which is pi over 8. And that's less than pi, so I keep that. That's one of my answers. So I'll go to, now I'm going to let my n is equal to 1. Okay, now notice I'm only taking positive values for n. That's because it's going from 0 to pi, which is positive direction. If I went 0 to negative pi, I got to take care of the negative values for the n also. Okay, so the next one is I'm going to let my n is equal to 1. So that will give me x is equal to pi over 8, because I'm substituting in right there. Okay, plus, okay, pi over 2. Okay, of course when I multiply top and bottom here by 4, that's going to give me 5 pi over 8, and that is still less than a pi, so I'm going to keep that. Then I'm going to let my n is equal to 2. My x is equal to pi over 8, okay, plus, when I put 2 right there, okay, that would be 2 pi over 2, they cancel, and that's going to give me 9 pi over 8, and that's more than a pi, so I'll have to stop right there. And that's it. I get 2 answers, pi 8s and 5 pi 8s. Alright, now comes the even more difficult one right here, which is number 8. Sine of 2x is equal to negative cosine of 2x. Okay. Easiest way to solve this one is to just know your unit circle. Now remember, at pi 4s, both sine and cosine are exactly the same. Okay? And at 5 pi 4s, both sine and cosine are exactly the same. Negative rad 2 over 2 and negative positive rad 2 over 2. But at 3 pi 4s and at 7 pi 4s, sine and cosine are exact opposite, and that's what we're looking at. We want where sine to be opposite of cosine. Okay, so we're looking at these two values right there. That's where sine and cosine are going to be exact opposite. What that means is, in here, when I have, if I put 3 pi 4s, okay, or 7 pi 4s, okay, these two equations will be equal to each other. Okay, now I don't have to worry about this, so let me erase that. I don't have to worry about that because I'm just concerned about this. What I have here is, now the difference between here and here is just a pi difference. Just a pi difference. Okay, so I don't necessarily have to now write that as a 2n pi. I can write that as just a n pi, 1 pi, because that's a straight line. That's just 1 pi difference. So I'm going to write 2x is equal to 3 pi over 4 plus or minus n pi. And my n is equal to 0, 1, 2, dot, 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 dot. Okay, I'm not done. I have to solve for x. I've got to divide by 2. So x is equal to 3 pi over 8 plus or minus n pi over 2. And my n is equal to 0, 1, 2, dot, dot, dot. Okay, that is done. Okay, now I still have to take care of this one, 7 pi fourths. So I'm going to do the same thing. We'll let my 2x is equal to 7 pi over 4 plus or minus n pi. And I'm going to, my n is 0, 1, 2, dot, 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 so on and so forth. N is equal to 0, 1, 2, dot, 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 dot. I'm going to divide everything by 2. So I'm going to get x is equal to 7 pi over 8 plus or minus n pi over 2. And there it is. And my n is equal to 0, 1, 2, dot, 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 dot. Okay, and that is my second set of answers. Okay, that means this is infinite number of answers. I don't have any domain restrictions. That's why I've come up with an infinite number of answers. All right, one last example. Okay, and we're only going to go up to section problem number 14 for Tuesday, and then we'll do the rest. We'll finish the rest of them on Wednesday. Okay, this is problem number 14. I have a 6 cosine of x plus 1 is equal to 5 secant of x. Okay, and then they do give us a domain restriction on this one. They said my x has to be greater than or equal to 0, but less than equal to 2 pi. So I'm including the endpoints. Okay. Now, first thing I have to do is I have to take everything to one side. So I'm going to take everything to one side. So I have a 6 cosine of x plus 1 minus 5 cosine of secant of x is equal to 0. Then I'm going to rewrite secant 6 cosine of x plus 1 minus 5. Secant is really 1 over cosine, so this would be 5 over cosine of x is equal to 0. Now I'm going to get rid of the fractions, so by multiplying everything by cosine of x, cosine of x, cosine of x, and cosine of x. Of course, on the right side, that's going to turn into 0 still. Here, their pi's cancel out. I get a negative 5. And then I have plus 1 cosine of x. And then I have a 6 cosine squared x. Right. So this is a quadratic. Okay. Hopefully we can factor. If we can't factor, then we have to use a quadratic formula. So let's try to factor this. I think we can factor this to 0. I get a 6 cosine of x times cosine of x. Those are the factors of 6 cosine of x. Then I got to make a 1 in the middle, but I need 5 out front. So I'm going to make a 5 here and 1 there, and I'm going to put a positive here and a minus there. Okay, so that works. It looks like that works. So this is factored. I'm going to set each factor 6 cosine of x minus 5 is equal to 0. I'm going to get cosine of x plus 1 is equal to 0. Okay, and then this one, okay, I am going to solve for cosine, so I'm going to get 6 cosine of x is equal to 5, and my cosine of x is going to be 5 over 6. Okay, and in this one, I'm going to get cosine of x is equal to negative 1. So far, so good. Okay. Let's do the easy one first. Cosine of x equals negative 1. Okay, between 0 and 2 pi, 0 and 2 pi, cosine is negative 1, only one place, which is right there, and that's at pi. So from this, I get x is equal to pi. Now I'm only going the positive direction, because it's going from 0 to 2 pi. I'm not going the negative direction. So that's one of my solutions. Okay, now comes the second part of this solution, is cosine of x equal 5 pi 6. So we're going to use that. That's not part of the unit circle, so we have to use our calculator for this. So you can use your scientific calculator. So we're going to take inverse of that. So x is equal to So I'm solving this now. So I'm going to take inverse of both sides, cosine inverse of 5 over 6. Okay, so when I take cosine inverse of 5 over 6, okay, I am going to get, okay, I need make sure you put this in, and I just have it in degrees, and it can't be in degrees. Make sure you put it in radians. So I have to go back and change my calculator to radians. Okay, now I change that to radians, and this turns out to be x is equal to 0.586. Okay, so that is my angle. Well, be careful. Okay, so your calculator only gives you one answer because cosine inverse only exists in 2 quadrants, but we're going all the way from left to right, from 0 to 2 pi. So what we found was at this angle, okay, this angle 0.586, okay, cosine is going to be 5/6. That's my 5/6. Okay, that's what it's saying. Okay, all right. So that's my positive value. But notice that that's my sine. This is the 5/6. Okay, what it's saying is my cosine is going to be 5/6. Okay, so that's my cosine right there. All right. Now, notice that I have to go all the way around. There's another angle that my calculator doesn't give me. So when I go all the way around in the 4th quadrant, okay, I'm going to get an angle too. Okay, this angle is going to have the same 5/6 for cosine, and I have to go find that. Your calculator will not give you that. So I got that answer. To find this answer, if I go, I have to subtract from 2 pi. So my x is equal to 2 pi minus 0.586, because all the way around is 2 pi, and I am 5.586 less than 2 pi. So I'm going to subtract that. So 2 pi is really 6.28. So let me subtract that real quick here. Decimal 6.28, and that turns out to be, okay, x is equal to 5.694. Alright, so I have that answer, 5.694, 0.586, and then pi, which is 3.